Hello, Math 126 fans. Going to go through page 1 of my Spring 25 Exam 2. It was essentially all about partial derivatives. Students did fairly well in it, so I'm not going to say very much on this page. I can tell you that on this particular problem here, this first one on this page, that 260 of the 460 students got a perfect score. That does mean we had about 200 students that missed something. I went through and looked at that, and the majority of those lost like 1 point because they made a calculation error. Now, this is a fairly prevalent issue I'm noticing. People, even if it's 1 point, it's not a big thing. But that's, I guess, the real takeaway there would be organization in how we practice the homework. But I'm also prone to these small things. But anyways, I thought it would be interesting. I mean, the moment you see linear approximation or tangent line, those are really the same things. So, as I mentioned in class, you could also write it this way. And if anybody got marked down for writing it in an equivalent way, just let me know. And I'll give you those points back, or you can ask in the... but if we write z by itself, we think of it as a linear approximation. This was really about the partial derivatives and the fact that if you're taking the derivative with respect to x, there's 1x here, there's 1x here, regular old derivative rules. If you're taking the derivative with respect to y, there's 2 y's in this term, and so you need the product rule. So hopefully that was your big first observation, and the rest was calculation. Now this function is this crazy thing over here because the signs that are in there, because the cosine, it's this wave that goes out. If we zoom in, the point in question was actually right here when x is 1 and y is 0. Anyways, and the tangent plane is this. So we found that tangent plane that's just touching there. So if you were really close to this point, then it might make sense. I mean, if you were extremely close, it might make sense to want to replace it with something simpler. And just say, okay, I'm near this point. Let's just use that. That's the idea. All right, the next one was an implicit partial derivative question. I noticed that a lot more students got that right. So I think the issue in the first one was really arithmetic with the people that missed that. So it was really, so most people did this very quickly. The first page should have been fast. That should not have taken long. I did hear students say that this exam still took them a long time, which I'd hoped I'd kind of help prevent by making this page quick. But I think, something about calculation. So we got to be a little more efficient. Okay, but the majority of students got this right. Students that got it wrong didn't realize they needed to use the product rule here. That's actually a big error. We typically take off a big chunk of points on that because z was a variable. But we did lots of this. This is on lots of my old exams, and I think that's why so many people did well on it. So again, the two variables we're looking at are, in this case, just x and z. Now, I did make you solve for dz dx, which I don't usually do, but it wasn't that bad. Okay. Just for fun, I also made this. Now, it's harder to do an implicit plot, but Desmos was able to do it. It looks like this. It's kind of cool. I computed the partial with respect to x and y. I thought just for comparison, I found a point that's on there, 1, 1, 0. So basically, I just figured out some numbers that work in there. And then I found the tangent plane. So there's the tangent plane at 1, 1, 0. Now, it's harder to find the tangent plane at other places because you first have to find a point that's on the curve. But that was the question I was originally going to ask, and then I decided to just simplify that part. All right, so I don't have much more to say on that. If you're somebody that's watching this video in a future quarter, I have other videos on partial derivatives. Lots of my old exams have practice with this. I have a review sheet on it. So I think I'm going to leave that at that. All right.